Right, this video is about ASA, Adaptive Security Appliance, which is a Cisco firewall, and the version that we are going to see is 8.4 version and above. In 8.4, a lot of new features like EIGRP support, like object-oriented approach towards ACL, NATing, and in the transparent firewall you can have a BVI, bridge virtual interface, and many more has been introduced in 8.2 version, sorry 8.4 version, which is not seen in 8.2 or 8.3 version. So our ASA that we are learning is capable of all this. It can be a DHCP client, it can be a DHCP server, it can be a dynamic DNS client, it can also support PPP over Ethernet, and in the routed mode, which is a default mode, it can support routing protocols like OSPF, EIGRP, RIP version 2, and static routes, default routes, and tracking the static route like using IPSLA. Not only that, it is also having rich NAT support now, which is object oriented, and it has also got support for IPv6, which was not there before, and multicast support. It also does integration of web cache communication protocol, right? Plus this also does virtualization. You can also do virtualization, meaning you can have a logically many number of firewalls, but physically it is one firewall. You can show as if you got more than one firewall by virtualization. We call it as context, multi-context, which will be coming in the following videos. Next, this firewall can also be made as transparent or routed. What is the difference between routed and transparent? Routed are layer 3 firewalls, transparent are layer 2 firewalls. That's nothing but bridge. ASA also supports redundant interfaces, which we are going to see in this video. It also supports Ether channel. What is the difference between this? Redundant interface means having more than one interface, having more than one interface, but considering as one interface. But both will not be active at a time. Only one will be active at a time. When one fails, the other standby becomes active. Whereas Ether channel is nothing but aggregation of Ether links. You bundle links together and consider as one logical link. And in here, Ether channel, all will be active. All interface will be active, right? And also, firewalls can do active standby failover, active failover, stateful, without stateful. There are huge difference in these words, stateful, without stateful, active, standby, active, which is going to come in the following videos. So this first video is about the basic configuration of ASA. For our understanding, I have taken an ASA here, and I got the CLI of ASA here. Our ASA is ready. I say enable, just blank password, you hit enter, it goes to the privilege mode, and then as usual, as you type in router, you type config T to get into the global configuration mode. The difference in this iOS is you can run show anywhere, in any mode, show interface IP brief. If you want to see interfaces, we used to type show IP interface brief. Instead, here we type show interface IP brief. It shows all the interfaces that the device has got. It has got G0, G1, G2, G3, and G4. Gig Ethernet. It is not E0, it is actually G0. Right. So we got these two interfaces for now. I think I may need to add one more interface to the inside. This is considered as inside. Router 4 and router 5 is considered as inside, highly secured zone of my network. And to teach redundant interface, which will be our last topic in this video, I may need another interface which I'll be adding later. So Ethernet or Gig Ethernet 0 is connected to outside. I consider R3 as internet, my ISP's router, and R2 and R1 as internet. This is outside. What you see in the left hand side is outside. What you see in the right hand side to the ASA is the inside. Now, as usual, as you give a host name to the router, you can also give host name to ASA. I'm giving ASA1. Right, the host name is given. Now, as you see running configuration in the router, you can also see here, but here it will be more, more granular. Show running host name. Look at this. This is not available in router iOS. You need to put pipe symbol. You need to say filter this, begin state, all the stuff. If you want to see show running interfaces, it will show all the interfaces alone. Very nice. By default, as usual, on all routing device, the interface will be shut down. In ASA, you have to give a zone name. You have to give a name for an interface. You need to assign a security level for an interface and the IP address as usual. That's the scenario for every interface. You got a name if, you got security level, you got IP address. Name if is nothing but the name that you want to give for the interface. Example, I will give for outside, out. Outside, for out I will give outside, for in I will give inside. Now it need not to be always inside and outside, it can be in and out, it can be my network, outside network, or our network, outside network, trusted network, untrusted. It can be any name. But I would like to have inside and outside and show you something that inside has got. Inside has got a special power. I should say that. I'll show you later what it is. Now we have got interfaces. I'm going to give an IP address to the interfaces. So interface G1. I'm inside gig 1 interface. I say no shut, as we do on every router, and then I give IP address. IP address that I want to have inside is 10.0.0.10/24. This is what the IP address I would like to give on the inside interface of my router, and on R4 the address that I would like to have is 4, and on R5 the address that I would like to have is 5. Right, so IP address 10.0.0.10. So we have to type the subnet mask if only subnetting has been done. See, the 10 is not class C, but it has got class C subnet. Only because of that I type this. Now on outside I'm going to have 192. I'll say 31.0.0.10/24. Is 192 subnetted? No. 192 is class C. The default subnet mask is 24. So when I give IP address to that interface G0, no shut, IP address 192.168.1.1 31.0.10, I need not to type the subnet mask. Right. So we have given no shutdown, we have given IP address. In our routers, when we give this to and say show IP interface brief, but here it is show interface IP brief. When I give this command, I used to see IP address on the routers, but that is not the case in ASA. Unless you put them into a proper zone, unless you give them a name, IP address will not come. See, show name if is the command. First, this name if, this show command should have some interface. Only then IP address will come on the show interface IP brief. Now if you see show run interfaces, you have given an IP address. You have given an IP address on this interface. But what is not given is name if is not given. Name is not given. Security level is not given. Unless you give this to, you won't have the IP address on the interface. You won't have IP address on the interface. So let us go to interface back and give name if. Name if for G0 I would like to give outside. It can be any case. But if your document says you need to follow this particular case, you follow exactly the same case. See, in our board there, we have used capital OUTSIDA. This place is very important. You have to match exactly the case that document has mentioned. Later on, when you use this outside name for NATing or for ACL, you need not to follow this case exactly. You can use any case as long as the spelling matches. It can retain the actual case. Now I have given a name if, but you also see security level also given. When you give a name, security level 0 is given. What is security level? We'll talk about that in some time. But security level 0 is the least secured interface. Untrusted, least trusted interface, 0. Security level 100 means highly trusted interface, the most trusted interface. Now why it has given 0? By default on firewall, anything other than inside will have security level 0. If you want to change it to some other security level, you can give this command, security level 50, 80, it's your wish. According to what your document says, you can do it. Now let me show you what we have done. Show name if. Look, we have given a name called outside to this interface G0, and it has got security level 0. Now if you go again back to the same interface and say security level 80, and when I type show name if, I got 80. From 0 it has changed to 80. So this is how you can change the security levels. So let me put back.
So if you change the name, will it go back to 0?
No, it's a good question. If I change a new name, I'm giving name if DMZ. Just the name gets changed, but not the security level. I want to show you that. See, just the name has got changed. So once you have altered the security level for an interface, that will be the security level, only the name gets changed. Now DMZ interface has got security level 80, let it be 80 now. I'll go to another interface called G1, no shut, IP address 10. Oh, it is already given, I think. Now I need to give just name if inside. Now you see what happens as soon as I hit enter. It gives security level 100. You can type inside in any case, uppercase, lowercase, mixed case. If it is INSIDE, Firewall considers that interface as more trusted interface. Any traffic that is coming inside that interface need not to be inspected because it is trusted. Alright, so I have given name if, and I also got security level dynamically assigned. Show name if. Look, for inside the security level is 100, which is currently configured. Now if I go and say show interface IP brief, I can see IP addresses. Right, so for IP address to be seen in this table, you need to have a security level, you need to have a name if. Done. What about the route? To see the routing table, we used to type show IP route, but here in ASA, show route, that's it. It has got 10 network on inside interface. We know what is inside interface, it is G1, but in routing table it will not show you the physical interface name. It will show you the alias name, the zone name, and 192.31 has got DMZ interface. Right, now we have seen how to assign IP address, how to assign security level. Optionally, if you want to change the duplex and speed of an interface, you can do this. If you want to change the speed, I'm sorry, that support is no more in 8.4 version. We used to set speed and duplex under the interface, no problem. So those are not allowed now. Okay, now we have got IP address on the interface. Now next, what I'm going to do is I'm going to show you that traffic from higher security level. Now, which is higher security level? Inside is a higher security level. Why? It has got security level of 100, and this interface is renamed as DMZ and has got security level of AG as for now. So about security level, if you see, traffic from higher security level will pass to the lower security level, but traffic from lower security level will not be allowed inside the higher security level. That is default. Traffic from higher security level is allowed to flow towards lower security level, but lower security level to higher security level traffics are not allowed. And there is also one more thing that we need to know, that traffic from same security level interface also will not flow. If you got two interfaces with same security level 100, even there traffic will not flow. Plus, traffic entering the interface will not be allowed to exit via the same interface. Traffic that enters into an interface will not be allowed to go out via the same interface. A kind of split horizon will not be allowed, but these two are default. By default, same security level will not talk. Two interfaces of same security level will not communicate. Traffic entering the interface will not exit via the same interface. But in some scenario, we need traffic entering via the same interface to be exited, like hub and spoke topology or harpooning in VPN. If you want that, you have a command to permit the traffic from same security level, like same security traffic permit inter-interface command. If you want to permit traffic entering via an interface to be exited via the same interface, again you got the command called same security traffic permit intra-interface, which we are going to see now in the next demonstration. Right. So before that, let us turn on these routers R3. I'll turn on R3 and R4. So router 3 and router 4 is ready now. I just turned on these two routers, and the ASA in the same condition. We got route and we got nameif, we got security level, and we got IP address show interface IP brief. Okay, let's go and start with router 3, which is an ISP for us. Interface fast Ethernet 0/0, no chat. IP address is 192.31.0.10, 255.255.255.0. We must type this in routers. In ASA it is not needed. Alright, so what else? As for now, in our design, I need not to consider R1 and R2, so I'll just write a default route pointing towards ASA. I'm writing a default route pointing towards ASA. Assume that there is no router 1 and router 2 here, so I say IP route. I'm sorry, there is an IP address conflict. I should have given here 3. No problem, I'll finish this. 192.13.0.10 is the gateway, so IP address cannot be 10. IP address should be 31.3, and even the static route I made a mistake. It is 31. Alright. Now, if I ping from here, I should be pinging 192.13.0.10, which is ASA. I will be pinging this address. See, again I made a mistake. It's not 13, it is 31. That's why it was not pinging. So 31. Show IP interface brief. Fast Ethernet. On ASA. Right? Interface fast Ethernet 0/0 shutdown. Sometime this will work. No shut. I think now it is going to work. Let me try from ASA. Ping 192.31.0.3. Something is wrong. Let me check with router 3. So what I did is I quickly changed the routers. Since we don't need many routers, I removed all routers and I have added fresh routers, R6, R7 and R8. And on R6 what I gave is I just gave the IP address and it pings, right? And let me write a default route also. IP route, sorry. Any network, any subnet must send the packet to 192.168.31.0.10. Right. So that is the address I have given as a gateway, and I am able to ping it. IP address on this router is 6. Right. Okay, now we are able to ping the outside interface of ASA, which was not really permitted in older ASAs. Now next one. On ASA, as you all know, show interface IP brief, it has got another interface called G1 and this IP address. So I would like to give an IP address on R7 with the same subnet. On R7 interface G0/0, no shutdown, IP address 10.0.0.4, 255.255.255.0, and from here I must be able to ping the gateway 10.0.0.10, which is ASA's address or firewall's address. I'm able to ping, and I would also like to write a default route here. IP route, any network, any subnet mask, send the traffic to 10.0.0.10. Alright. Then R7 able to ping ASA. Likewise, ASA also pings 10.0.0.7. What did I give? Did I give 10.7 there? 4 I have given. Oh, okay, no problem. So from ASA, if I ping 4, I am able to ping 4. Perfect. Likewise, if you want to add router 8, you can add. We'll add it later if you want. Now going back to ASA, I have a route. I have a route to reach both the networks that is adjacent. What if I have a route behind R6? Behind R6, interface loopback 6, I would like to give IP address 166.0.0.6. Fully masked. So I got a loopback interface with 166.0.0.6. If I want to ping that 166, see, this is outside for us. This is outside or DMZ for us. Let's say DMZ has got many networks. So I'm not going to write static route precisely for every network like 166 and so on. I'd like to write a default route. This is how we write default route. Route outside. Route outside. Something is wrong. Route. Oh, we don't have outside interface. We have changed it to DMZ. Okay, route DMZ. Look at this. I put small d, but still it is accepting. So initially, when you give a name for the interface, that is very important. DMZ. I'm saying I press tab and it will fill the remaining word. I'm saying any network. So you need not to type 0.0.0.0. You simply type 0. Any network, any subnet mask. Send it to 192.31.0.6. Now show route. I'm having a default route pointing towards DMZ interface. Pointing via any traffic that this router don't know, it will go via DMZ interface. Now pinging from here 166, is that right? 116. What is the loopback address I gave? 166, correct. So pinging from here 166.0.0.6 is possible. Alright. Now similarly, let's say R7 has got a loopback interface. Interface loopback 7, IP address 7.0.0.7, 255.255.255.255. So router 7 has got a loopback interface with this IP address. So how I'm going to write a static route on ASA to reach this loopback? Route via which interface? Inside interface 7.0.0.7 255.255.255.255. I need to send the traffic to 10.0.0.4. So let us check show route. It's not show IP route, it is show route. I got a static route for that. So if I ping from here, ping 7.0.0.7, I'm able to ping. So from ASA you are pinging adjacent routers. Now router 7 is in higher security level, we all know, 100. Whereas router 6 is in lower security level. What we learned is traffic from lower security level to higher security level will not go. Traffic from higher to lower will go. Higher to lower will go. So this is higher. If I ping from R7 to R6, the ping should go. See here. I'm going to router 6 and saying debug IP ICMP. From router 7, I am pinging 166.0.0.6, and when I go to router 6, I am getting echo reply. Echo reply is sent back. Router 6 is receiving an echo request, ICMP echo request. It is sending an echo reply to 10.4 back, which means from higher security level to lower security level, traffics are allowed to pass on ASA. If ASA doesn't allow, this reply will not go back. But when I go to R7, R7 sees no reply. Why? ASA by default, you know that traffic from lower security level 80 will not be allowed to higher security level. So unless a policy permits or ACL permits, you can write policies by writing ACL. You can also use MPF to write policies on ASC to permit this. See, for example, when I write an ACL like this, access list. This is not the ACL as you wrote in routers. Here no standard ACL, extended ACL. It is ACL. By default, it is only extended only in ASAs. Access list, I'm saying out or DMZ to inside. Give any name. Okay, if I type like this, you may think that I'm matching with the name, interface name. No, D to I. Permit ICMP from any to any. I'm writing permit ICMP any to any. By default not permitted. By default only TCP UDP is permitted. Only inspected. See, traffic coming from lower security level to higher security level has to be inspected. Otherwise it will not be allowed. By default only TCP UDP and few exceptional protocols like FTPs are inspected. So if you want to inspect, if you want to permit ICMP, you need to inspect or write an ACL like this. Explicitly we have to permit. So I have written an ACL. Now I need to bind this to an interface. It is not like as you bind in a router. Here it is different. Access group D-I means, this is the name of the access list that is permitting ICMP. D-I in means, permit inside via which interface? DMZ interface. Permit whatever matches here, permit them inside, allow him to come in via which interface? DMZ. It is DMZ the one which is not allowing the echo reply to come in.
Is it not inspecting?
It is letting in, not inspecting. Inspecting is another way of permitting ICMP traffic. Now if you see, pinging from 7 to 6 is possible. So by default, traffic from lower security level to higher security level are not permitted. But you need to write an ACL and permit. Now what I am going to do is I am going to delete this ACL. I have deleted this ACL. After deleting, I am showing you it is not pinging. But R6 is trying to respond back because higher to lower should be permitted. I want to show you by default for telnet return traffic is allowed. Statefulness will be maintained and return traffic is allowed. By default for UDP and TCP, if traffic originates from inside to outside, return traffic from outside to inside is allowed. For ICMP, not allowed. That's what I mean when I say inspection is there for TCP and UDP. So telnet cannot happen from 6 to 7 because lower security, higher security, but telnet can happen from 7 to 6. And return traffic from 6 to 7 also permitted by default. I want to show you that. For that, let me enable telnet and SSH on R6. Line VTY 0 to 4, password, or let us use the login local, username R7, password 7. Right now what I'm going to do is I'm going to telnet from R7. Telnet 166.0.0.6. Telnet is allowed. How? See this ASA. Show connections. It says any traffic coming from this with this port number wants to go back to inside interface to this destination port number is allowed. Statefulness is maintained. See, when R7 was telnetting, this was the source port number and source IP address, and this was the destination port number. Because you are telnetting from R7, destination port number will be 23. For that, a return packet, return path is dynamically allowed. This is what inspection. By default, TCP UDP inspection happens. Now, because of that, when I type R7 username, password SEVEN, I am able to see R6. Right, so exit. But when you try telnetting from 6, let me enable telnet on R7. Username R6, password 6. Line VTY 0 to 4, login local. Now when I telnet from here, telnet 7.0.0.7, Not happening. Why? Lower security to higher security, no inspection. Not allowed. Not allowed at all. Not allowed at all. Right. Next what we are going to do is same security. Same security by default not allowed. Let me show you that. On ASA, interface G0 has got security level of 80. Now I'm going to say no, security level is 100. Now if you see, inside as well as DMZ has got same security level 100. Let us verify once. Show name if. You see, same security. Even now the telnet is not going to happen. See, previously you were at least able to telnet from 7 to 6. Now it is not allowed. Why? Same security not allowed. Previously it was higher and lower, it was allowed. Now 7 to 6 is also not allowed. Inside to DMZ is also not allowed. If you want to permit same security traffic to pass, we need to type in the command same security traffic permit interface between the interface. When you do that, this telnet is possible. I'm saying R7 SEVEN. Likewise on R6 also you can able to telnet now. Why? Because it is not lower or higher, it is same. R6 6 R6 SIX. Right. So telnet happens. Let's go and check on the ASA. Show connections. You see, return traffics are permitted from 7.7 to 192.131.6, that is router 6. Similarly, from 10.4 to 166 is allowed. Right? So same security traffics are allowed.
So it still does the inspection thing.
Yeah, it inspects because both are same security level, high security. Inspection will happen now because you change the security level. Right. Only from lower to higher will not happen. Higher to lower will happen. And same security will also happen, but not by default, after giving this command same security traffic permit interface. Now, assume you got this G0 interface. Assume you got G0 interface like this. You want traffic coming via this G0 to be returned back via the same interface, sent via the same interface, which is not by default. I cannot demonstrate it now here in this topology. In case if you want traffic coming from 6 to G0 to send back to 6 for some reason, some sort of hub and spoke design you got, and the ASA G0 interface acts as a hub, then you may need to type in this command, same security permit intra interface. Within the same interface, enter and exit. Unless you type this command, hub and spoke will not work, will not happen. Alright, next thing what I would like to show you is redundant interface. Redundant interface is not like ether channel. In ether channel you got all interfaces active and they are redundant as well. Here redundant interface in ASA is different. See, like this we say interface redundant 1. This is how we create a logical interface. In ASA there is no logical interface like loopback and all. We got something called redundant here now. I can put some interface as a member of this redundant interface, but only one will be active, the other will be standby. Whichever you make it as a member, member G1, gig Ethernet 1. That interface becomes active. If I say G2 first, then G2 will become active first. If I say G1 first, G1 will become active. Now I am saying member interface G1. The moment I say this, it says, I'm sorry, you got some name inside that interface. So you remember we gave name, if, IP address, all the stuff. Now when you put these two interfaces as a member of redundant interface, only one can be active, the other cannot be active, other will be standby. When the active goes down, standby will become active automatically. So you need to give an IP address not on the physical interface but on the redundant interface. Why? The IP address and the name that you're going to give is common for both the interface. So let me go to interface, or I'll say clear config, clear config interface gig 1. When I say this, everything that was configured under that interface is cleared. I want to show you that. Show run interface G1. You see? No IP address, nothing now. Now I'll say interface redundant 1, member interface G1. Now it says everything is cleared. It is clear. It is just an information. It's not an error. Security level IP address are cleared on the interface, which we only cleared. Previously it was showing an error because we were having some IP address and security level. Now one more member interface G2. Now why should I give two interface? When one goes down, the other can become the redundant, other can become active, but not both will be active. Both will not be active. Now which one will be active? The one you configured first will be active. So before you say this thing, make sure you go under interface G2 and say no shut, and G1 no shut. Nothing more than this is required. Show interface IP brief. You see, no shut is given on these two interface, and redundant interface is there up. Once again I will go to interface redundant 1, or before that, show interface redundant 1. You see redundant 1 has got two interfaces. G2 is active now, G1 is standby. Alright, so when I type show interface redundant, it shows these are the two interfaces that has become member G2, and G1 is now currently but which is active? G2 is active. How many interface you can make a member? Only two interface, and out of two only one will be active, the other will be standby. Now I need to give an IP address. Unless I give an IP address, I cannot see show interface IP brief. I'm not seeing IP address here, so I need to assign an IP address interface redundant 1.
How that became a member interface G1?
That's abnormal actually. Whatever you configure first will become member, and then the second one will become standby. We'll check it one more time later, okay, in some other scenario. Now IP address, I'll say 10.0.0.10, 255.255.255.0. Maybe this 8.4 may have some preemption, like one with a bigger interface name should become active. That we need to check in another scenario some other time. Okay, now I have given IP address to the redundant interface. Will I see the IP address now? No. Why I will not see? Because I have not given name if. So let us say name if inside. Immediately it has got 100 security level. Right, and now if I say interface brief, I have got IP address. Show name if. See, interface redundant 1 has got name inside and it is 100. Now if I ping from here, 10.0.0.4, I am able to ping. What about the loop? I am able to ping. I will ping. Okay, the reason why, previously we deleted the configuration that we did under G1. G1 was having inside name. We deleted it. When we delete that, the static route that we wrote with the using inside keyword is also deleted. See, show route. There is no static route for 7. So our route inside 7.0.0.7 255.255.255 has to be sent to 10.0.0. Right. So now if I ping, it will ping. It pings. Which one is active? Show interface redundant 1. Active is G2. It is pinging via G2. Now let us shut down G2. Interface G2 shut down. Shut down. Let me check that command. Because it's a GNS, it has a limitation. See, this is still going green. It's not going red when I shut down. That's why. But the ping will not happen now. You see, because the interface is shut down, ping will not happen. But redundant interface has not changed from G2 to G1. In real device, it will change. There is also one more command to force G1 to become member. What is the command? So how we can? It's by giving this command: interface redundant interface redundant 1 active member gig 2. When I type in this, gig 2 becomes the active member. When you type show interface redundant 1, you will see in the real device G2 becoming active immediately. In this simulator, you may not be seeing that. Alright, as for now, maybe when they do some more improvement in the simulator, you may have this done. But in real device, it happens immediately. This is how we use redundant interface on ASA. The redundant interface on ASA. Now, if I ping or if I telnet from here, I need to be okay. It's happening. R7 7. It happens. So, hope we understood the basic configuration of ASA. And then the security levels, name if, and redundant interface, same security level, interface, how to permit traffic, if interface receives the traffic and if it needs to exit via the same interface, the same traffic, intra-interface security permit, and then we also saw a higher security level to lower security level traffic.